Good morning. I am Dr. Sushnitha, Assistant Professor of Civil Engineering Department, G. Pullareddy Engineering College, Kurnool. So in the previous videos, I discussed brief introduction to highway engineering and railway engineering in the previous modules. So here in this module of multimodal transportation engineering, I am going to discuss some basics of railway engineering and how to orient runway in airport construction. So airport engineering is branch of engineering in which design, building and maintenance of an airport facility will be done. So airports are designed in order to serve a number of roles. Key functions include providing railways for aircraft to take off and land, as well as terminals for safe loading and unloading of passengers as well as cargo. So there are some important definitions. Airport. So airport is a facility where passengers connect from ground transportation to air transportation, or otherwise we can define it as a location where aeroplanes and helicopters take off and land. So next we have a term airfield. So airfield is the area where an aircraft can land and take off, which may or may not be equipped with any navigational aids or markings. Next we have aerodromes. So it is a defined area on land or water which is intended to be used either wholly or in part for the arrival, departure and surface movement of the aircraft. So you can observe this is the airfield. So it is the area where landing and takeoff will happen. So this is a figure showing aerodromes. So what are different types of airports in general we have? So we have in general three types of airports: international airports, domestic airports and regional airports. So internal airports have they provide direct service to many other airports and it handles scheduled commercial for both passengers and cargo. So they provide facilities for international transportation also. So in case of domestic airports, it handles only domestic flights within the country. Regional airport, it is airport serving traffic within a relatively small or lightly populated geographical area. Okay. So how to select a site for airport construction and what are the factors to be considered when you are going to select a site for airport construction? So we have several factors here. Let us see one by one. So first one is regional plan. First you need to select the plan. Okay, so regional plan of that particular area where you are going to locate your airport. So next you need to consider use of the airport, whether it is for civilian purpose or military purpose. So next factor that you need to consider is proximity to other airports. So the site should be selected at a considerable distance from the existing airports, so whenever the aircraft is landing in one airport, so it does not interfere with movement of the aircraft at another airport. So next factor you need to consider is ground accessibility. The site should be so selected that it is readily accessible to the users. So airline passenger is more concerned with his door-to-door time rather than actual time in the air travel. So time to reach the airport is also important consideration, especially for short haul operations. Next we have topography, which includes natural features like ground contours, trees, streams, etc. So a raised ground or hilltop is usually considered to be an ideal site for the airport construction. So next you need to consider whether any obstructions are there. So when aircraft is landing or taking off, it does not loses or gains altitude very slowly as compared to the forward speed. For this reason, long clearance areas are provided on either side of the runway, known as approach areas, over which the aircraft can easily safely gain or lose its altitude. Visibility. Poor visibility lowers the traffic capacity of the aircraft. So the site which you are going to select for the airport construction must be very clear weather must have very clear weather condition. So next, wind. So wind is the main component or main factor which you need to consider for airport construction. So always runway is oriented in the opposite direction to the wind, because there must be a force which must stop the aeroplane while it is landing on the runway, so that it can easily stop at considered point. So next, noise nuisance. So the extent of noise nuisance depend upon the climb out path of aircraft type of engine propulsion and the gross weight of the aircraft. So this problem becomes more acute with jet engine aircraft. So the site should be so selected that the landing and takeoff paths of the aircrafts pass over the land which is free from the residential areas or industrial development. So we have next factor, grading, drainage and soil characteristics. Drainage and grading plays an important role in construction and maintenance of the airport, which in turn influences the site selection. So the possibility of floods, water table level should be investigated before going to select the site for airport construction. Next, you need to consider future development also. Okay, so considering that, so today we have some air traffic volume. In future and after 10 years, it may get increased. So you need to consider the site for future development also, not for today's development. You need to consider it for future development. So next, availability of utilities from town. So it should be provided with facilities like water supply, sewer lines, telephone and electricity, etc. So next, economic considerations. So whenever you go for any construction, its construction cost, maintenance cost, operation cost, overall cost must be economical. Okay, so whenever its construction, maintenance and operation cost is minimum, so then only we can say that the site is economical site and which can be suitable for the construction of the airport. Okay, so these are different factors which you need to consider before going to select a site for airport. So next topic is runway orientation. How to orient your runway. So what is the direction of the runway? So after selecting the site, you need to select the runway orientation. So runway orientation mainly depends on blowing direction of the wind at that particular site. So how the wind is blowing, with what intensity it is blowing, with what duration it is blowing, and it is considered over a period of 10 years systematically. So and for this runway orientation, we use windrows diagram. Okay, so a runway orientation is a rectangle. A runway is a rectangular area on the airport surface prepared for the takeoff and landing of the aircraft. So it is generally oriented in the direction opposite to the direction of the wind blowing. So the headwind, that is the direction of the wind opposite to the direction of the landing and takeoff, provides greater lift on the wings of the aircraft when it is taking off. So crosswind component, we call it as V sin theta, where theta is angle of wind direction to runway center line. Normal component of the wind is called wind component. The maximum permissible crosswind component depends upon size of the aircraft and wing configuration. So wind data would be collected typically over a period of 10 years and is systematically arranged on a diagram called windrows diagram. So we have windrows diagram which is used for orientation of the runway. So for orientation of the runway, we need this data, that is direction and with how much speed the wind is blowing and duration percentage of the wind and total percentage of the time with blow between 6 to 60 kmph speed. So windrose diagram is a diagram which represents orientation of the runway. So it is a compass shaped diagram. It exhibits wind direction, duration and speed range. So it shows wind speed also. So it is used in working out the orientation of the runway. So we have in general mainly two types of windrose diagrams, type 1 diagram and type 2 diagram. So windrose diagram of type 1 shows direction and duration of the wind only. So when you consider type 2 diagram of windrose diagram, so it shows direction, duration and speed of the wind. So let us discuss windrose diagram of type 1. So here we have how to construct windrose diagram of type 1. So in step 1, draw concentric circles showing wind duration. Okay, so first you need to draw concentric circles which represents duration of the wind. So in step 2, divide the circles into 16 segments which shows 16 directions. So in step 3, plot the wind duration along the respective direction and join all the points. So in step 4, runway is oriented along the longest line of the diagram. Okay, so here you can see first a concentric circles are drawn. Okay, so which represents wind duration. Next directions are shown. Okay, so duration of the wind is plotted along its direction. So for suppose the duration of the wind along north direction is 10.3. So you need to locate 10.3 along the north direction. So northeast direction is having a wind duration of 8.1. So you need to locate 8.1 along northeast direction. So similarly, along all the 16 directions, you locate the points which represents the duration of the wind. Finally, join all the points along which we already marked along 16 directions. So the longest direction which you get in this plot is the correct orientation of the runway according to type 1 type of the windrose diagram. Okay, so next type 2 diagram of windrose diagram. So here what is the difference between type 1 and type 2? So in type 2 we especially represents wind speed also. So in type 1 we represent only wind direction and wind duration only. So in type 2 diagram we represent wind speed also along with duration and direction. So first draw the concentric circles which represents wind speed. Okay, so here the portion which is covering in these circles with below 6 kmph speed is known as calm period. So in step 2, mark 16 directions, each with wind coverage area of 22.5 degrees centigrade. So in these concentric circles, you mark all the 16 directions like this. Okay, so in step 3, draw radial lines to show the wind coverage area. This creates segments in which wind coverage percentage time is written. Okay, so in step 4, mark calm period, so which we already discussed now. So the area covered in this windrose diagram with less than 6 kmph speed is known as calm period. 6.4 kmph is known as calm period, so which is shown with blue color in this diagram. So step 5, so in step 5, so fill all the data along the each direction which represents duration of the wind. So for example, here in this table, from 6 to 25 kmph, with 6 to 25 kmph speed along the north direction, we have 7.4% of the duration of the wind. So here you can observe 7.4 is marked in between 6 to 24 kmph speed and also along the north direction. So similarly, in this table, all the durations of the wind in between the speeds and along all the 16 directions is shown. So you fill all this table data in this diagram. Okay, respective data. So in step 6, how to determine orientation of the runway. So here in this step 6, you cut a transparent strip of width equal to crosswind component along the direction. Add the wind coverage percentages superimposed by the strip plus calm period. Then place the strip along all the other directions also. So you can see how the transparent strip is placed here. So in this transparent slip, under which whatever the values are there, you add all the values. Okay. So next, change the orientation. So the area covered in this orientation, you fill, which is filled with some values, you add all the values. So in this orientation also, you add all the values. So here also, you add all the values. So in this coverage also, you sum up all the values. So next, change the orientation like this, and you go on adding the values which are covered under this strip. So next, change the orientation and add all the values under this strip. Next, change the orientation and add all the values which are covering under this slip. Okay. So whenever you are adding all these values by changing the orientation, okay, so the largest value which you get, for which direction you are getting, that is the orientation of the runway. Okay. So by changing all these orientation, you are adding all these values. So for which direction you are getting maximum value, so that is the orientation of your runway in the type 2 windrows diagram. Okay. Thank you.